Girish, we are live, sir. Please go ahead.
Okay. Thanks.
Thank
Thanks,
you.
Manish. Hi, everyone. A very welcome. Good evening. And so today we will be having the course orientation for two courses of the second term, which is digital systems, and another course is electrical and electronic circuits. So this orientation is mainly on the course only, and it is not related to any admin or operations related. So if you have any questions related to admin, kindly hold on, and you will have a separate session for that. So that will be having a separate session for answering all your queries. So you can ask at that time, or you can also send us an email, or you can call us over phone. So so after the today's session, that is after the professor's presentation, if you have any questions, you can ask, but it should be only related to the course. So that is what I just wanted to tell. So welcome, professors, and over to you.
Yeah, thank you, Girish. Can you hear me?
Yes, professor, I can hear you.
Can you see my screen?
Yes, we can see you.
Okay, great. So, welcome all of you to this orientation program for the digital systems course that you are going to do in the current semester. Okay. I have a more detailed introduction video that I had recorded, which is part of the course. But let me just take you through this. Okay. So essentially, I'll skip the motivation and all that, but because that is part of the actual course, right? So the focus really is, in this course is to sort of build combinational and sequential blocks to achieve a certain functionality. Okay, so all of you are aware of, what a microprocessor is, because all of us use desktops, we use laptops, and we use mobile phones. All these gadgets are powered by a microprocessor internally. And we are also aware from the experience with C programming that you can program a microprocessor to do any task or perform some computation or anything, right? So the idea is the building block of this microprocessor is what is known as an arithmetic logic unit. And that has certain, blocks that can perform arithmetic operations and logic operations. The focus of this course, right, is sort of to figure out how to build these arithmetic and logic operations, right? So eventually, when you are done with your program, right, the BS program, you should know how to build a microprocessor, right? And this is the building block for that idea. Okay, so we will be dealing essentially with combinational and sequential circuits. Okay. uh, so also, it's also very interesting to know, to be aware that, okay, how complex is a microprocessor today? Okay. So, if you look at it, what I've shown here are the server microprocessors. Okay. This is not your desktop, right? These are way more powerful microprocessors that come from IBM, right? Your desktops are also very complex these days, but effectively it's like, the area of a microprocessor, the chip itself is some 695 micron mm square. So it's a 25 mm by 25 mm, which is the size of a 10 rupee coin. Okay, effectively it's like a 10 rupee coin that you have today, and in that you have about 8 billion transistors that are accommodated, and in the latest microprocessor it is 18 billion transistors. Okay, billion is 10 power 9. Okay, it's kilo, million, and billion. That's how it goes. In 3 orders of magnitude you jump. And effectively these microprocessors are super complex. Okay. So let me just pose a question here to the students. Okay, see, what responses I get. Maybe can you put it in your chat? Okay, so in a microprocessor you can connect one transistor to the other using a wire, right, or an interconnect. Okay, so suppose I take all this interconnect from a microprocessor and just line them up one after the other, right? Just make one straight line. So every interconnect I just take, that distance I keep adding. How much of a distance do you think I would cover with this? Please put it in the chat box. Please put your answers in the chat box. Okay, remember the microprocessor is 25 mm by 25 mm. That means it is the size of a 10 rupee coin. So inside this, how much? Okay, I see an answer, few kilometers, a kilometer maybe. Okay, any other answer? So let me then ask you another question, right? The whole earth, okay, that's a lot. Okay, so let me ask you the question, right? Okay, few centimeters. Okay, so the question is, if you take, all the wires inside a microprocessor and just stack them up one after the other, right? How much distance do you think I'll cover with that? That's the question. So some people said few centimeters. Okay, few centimeters. Okay, so you have a 25 mm by 25 mm microprocessor, and how few meters. Okay, so okay, great. Okay, fine. I think I have got sufficient, spectrum of answers here. So the answer really is about 11 kilometers. Okay, for this IBM microprocessor that I'm talking about, it's about 11 kilometers. Okay, so the fact is a 25 mm by 25 mm, 2.5 centimeter by 2.5 centimeter, is able to actually host about 11 kilometers of wires. Okay, and that is how miniature your microprocessor is today, right? So that is how, in fact, we had also seen this in the electronic systems course, where we had shown you how small all these components are when we ripped apart the mobile phone, right? And even the laptop for that matter, right? So fundamentally, you are able to do so much. And the heart of this is, is really the arithmetic and logical unit. Okay, and of course, I am just giving you this information because you should know where we are heading. Ultimately, we want to be able to build a microprocessor. Okay, and we are not there yet. This course, digital systems, is just the stepping stone to that course. Okay, so essentially, I will just go through, why you should be studying this course. Okay, like I said, it's a fundamental digital logic design course. It's your first introduction to digital computation. Essential to understand and build microprocessors. It's also essential to understand how to code in hardware description languages, right? Later, you will be exposed to Verilog and other things. Right now, you are only aware of programming languages like C and Python and all that. But hardware description languages, though it's a programming language, it's very different from all these languages. So unless you understand the hardware itself, you will not be able to program or write hardware description code very efficiently. Okay, and of course, you need to understand state machines and control that efficiently. Okay, so the course really will comprise of 3 modules, approximately, and I'm thinking it will take 4 weeks each, right? Or maybe not 4 weeks each. The mathematical background will take about 2 weeks. Then maybe about 5 weeks each of combinational and sequential circuit design, right? So inside this, there are further sub-modules, but I will not go into that right now. What are the learning objectives of this course? The learning objective is something you should be able to do as a student after completing this course. So at a top level, at a high level, after finishing this course, you should be able to design arbitrary combinational logic circuits, use sequential circuits to sequence events in a pipeline. Okay, we will discuss all these terms in great detail in this course. Most importantly, you should be able to design a finite state machine. Okay, so right now I understand these might just be terms and these might just be jargons, but it's good to just keep this in mind. Okay, most importantly, what is this course not about? Right, I also want to clarify, this course is not about automated tool flow. Okay, we are not, because typically ICs today are designed with a lot of automation. Okay, This is not about that kind of automation. Neither is this about Verilog design. Okay, we will not be writing a single line of Verilog code or VHDL code, any hardware description language in this course, right? And it's also not about microprocessor instruction design, right? It's unlikely you might expect any of this, but I'm just putting it up here for clarification. Okay. Unlike the electronic systems and thinking course, where we didn't have like a textbook because the course was sort of designed for the first time for this program, this is a standard course, digital system, and basically the book is called Digital Design by Maurice Mano, the sixth edition Pearson Education, and I strongly recommend that all of you buy the Indian edition of this book. It's not very expensive. It is available on Amazon or any other bookshop. Please do buy a textbook. Buy this textbook because there are numerous worked out examples, problems behind each chapter that you can do in addition to the tutorials and problems that we give you in this course. Okay. So with that brief introduction, I will stop and I will take any questions that you may have with regard to this course.
Good evening, sir.
Yeah.
Sir, I just have one question. We will be required to go to the campus for lab sessions for this particular subject?
Not this subject. There is a separate lab which will involve digital experiments, and you will have to come to the campus for that. But it has nothing to do with this course.
Okay, okay. So this course does not engage in campus lab, right?
No.
Okay, sir. Thank you.
Yeah. Yes.
Sir, by the end of this course, we'll be only able to have the basic understanding of the logic gates or the whole microprocessors thing.
No, I said you will be able to build a finite state machine. That's the end goal.
Oh, okay, sir.
Okay, and finite state machine is basically what you need to control a microprocessor. The control unit basically goes through some finite states.
Oh, yes, sir.
So that's the idea. Yeah. Any software, hardware required? No, nothing. This is a theory course. It's a conceptual theory course that will be taught. Yeah. Anything else?
Sir,
Yeah.
sir, I have a small doubt, sir. Sir,
Yeah.
in this digital design course, from the previous course of electronic systems and thinking, for some concepts I have referred to the William textbook, sir. In that, they have also specified the Thevenin and Norton equivalent, which we have not covered in the electronic systems course, sir. So,
No.
will we be covering in this course?
That will come in the electric and electronic circuits that Professor Anirudhan and Bobby will be talking about next.
Okay, sir.
Yeah.
Sir, I have a question. Can I ask?
Please.
So the book which you have mentioned right here,
Yeah.
which is 6th edition. So if new edition is available, can we follow that?
Okay. I thought I had mentioned the latest edition because I bought it very recently. If there is a later edition, I think that's okay. Yeah.
Okay, fine. Thank you, sir.
Okay. Will these courses coincide with control systems? No. Any advice? Okay. So first of all, I think very importantly, for those of you who are already doing an electrical or electronics or a computer science degree in a regular college, this is exactly identical to the digital systems course that you will do in that curriculum. It's exactly the same concepts that will be taught here. Okay, they might cover a little more than what I would cover here, but whatever is covered will be exactly identical to that. So if you are, I don't know if it comes in the second semester or third semester, but if it is coming, if you are aware that it is coming, this will essentially be either a direct overlap with, with that course if you're doing it right now, or effectively by doing this now, that other course will become very easy for you in the college there. Any advice to feel familiar? No, nothing. I think you just follow the lectures step by step. Please work out enough examples from the textbook. You should be fine.
Professor, one question. This machine state you will be able to implement on the breadboard. Some experiment will be given to us.
No. That will be too complex. Okay. In some sense, it will be. In some sense, it will be. Okay. But not. It may be too complex to build something from scratch. But effectively, you will see a finite state machine in some way or the other.
Okay. Yeah. Thank you, Professor.
Okay.
Sir, I have a question.
Yeah.
So, we have to buy something electronic device for this course?
No, nothing.
Okay.
So, by the way, what do you people understand by finite state machine? Can you name a finite state machine that you have seen?
Finite state?
Anyone, any one of you, what do you understand by finite state machine? Because you are asking questions, I just want to understand. Yeah.
So, actually, I think it's a particular machine which has a finite number of state outputs, such as a counter or something like that.
Yeah, but where have you seen it?
Actually, I
Sir,
haven't seen it.
and more model, I guess so.
No. Don't give me jargons. Where have you seen it in your daily life? Where do you see this?
In our daily life,
In
suppose, sir,
transistor or diodes, we can see in the multi-stage program.
No. In your daily life, you cannot exactly. Thank you, Atish Shah. Traffic light.
Sir, vending machines.
Traffic light, sir.
Traffic light. Your counter there, right? Your signal counter. Green. When it goes green, it will count down from a certain time to when it goes to 0, it will go to red. Right? That is basically a finite state machine.
Sir, cash counting machines in the banks.
Sir, digital clock, sir. Digital clock.
Digital clock also. Yes. Okay. But definitely the traffic light counters are the most common finite state machines. And in this course, you may end up building one such counter. Okay. Yeah. Okay. Any other question?
Good evening, sir.
Yes.
Sir, how you relate this course with our previous one? Like ESTC, we have done in our first term, and now
Correct.
we have basic digital system and electrical and electronic circuits. So how you relate with all these three?
Yeah. So in week 10 of electronic systems thinking and circuits, we did this analog to digital conversion, right? We did
Yes, sir.
time quantization, amplitude quantization, and then we spoke about what happens in a digital computer. Do you remember? How do you take
Yes,
that
sir.
signal into a? You remember we calculated the size of a wave file.
Yes, sir. In
Right?
bits in binary system, we have done that.
Exactly, right? So now this course takes off from there. So you have an analog to digital converter, you get something into the computer. How can you do any arbitrary computation, digital computation inside that computer? That's the question that we are going to ask in this course and answer.
Okay.
Yeah. And that is there in my video, by the way. The introductory video, I start from there.
Okay.
Saying this is what we saw. Now, how do we go forward from here? Okay.
Okay.
Yeah.
Okay. Thank you, sir.
That's a good question. Yeah. Anything else?
I have one more question. So, sir, are we going to deal with the programming of the microprocessors and the language, the assembly level language, something like that?
No, I told you, it's not about microprocessors. I just told you that the eventual goal is microprocessor, right? And this is just the stepping stone there. This is the first step.
Only the digital, only the digital segment. We will be studying up to the memory block or something like that.
Not even memory.
Okay.
Because memory is again too advanced for this course. I may just introduce it and leave it, but memories may be very hard. Yeah.
Okay. Thank you.
Okay. Yeah.
Sir, one thing.
Yeah.
Do programmings require in this BDS which we study here now?
No. Can you repeat the question? I'm sorry.
Means any type of programming would be required here.
No.
Means for counting anything or for any digital system.
No. Just some very elementary logic is needed. That's all. But no idea of programming and no.
Sir, so
Okay,
this
sir.
course is basically like logic based, right?
Yes, it is logic design. Exactly, it is. That's what it is.
I think this is basically for the design of basic building blocks of digital systems and all that. Like
Yeah.
ADC, the microcontroller, because microcontroller includes all that very different parts are there.
Yeah.
And before that, we have that input output parts is there, ADC is there, counter is there, timer is there. I think so. Building
Yeah.
blocks of all these parts and basic systems, like I think.
Correct. Yeah.
Okay.
Okay. I think in the interest of time, I will stop here. Okay. I'll hand it over to Professor Aniruddhan and Professor Bobby. Okay. Hemant, you have the last question.
Will there be recorded classes after you teach every class?
You mean will there be live sessions?
No, sir. Sometimes due to college timings, I cannot attend every class. So will there be proper recorded sessions?
No, the live sessions are always shared, no? Girish, can you clarify?
Yeah. Live sessions, you can always check live sessions will be there. So that
Yeah, but
you
in
can
case
check
if I
always.
can't attend the live ones,
No, that's what it will be there in the in the YouTube. You can check that in case if you're not able to attend the live session. It is there in the YouTube. You can always check that.
Okay.
Yeah.
Thank you.
Yeah. Okay. Okay. Great. Then thank you all. I'll stop here. I have to drop off for another meeting. Okay. So I assume I have answered most questions. Otherwise, I will definitely catch up with all of you midway through the course. Okay.
Thank you, sir.
Yeah. Thank you. Yeah. Bye, Girish.
Okay, thanks.
Yeah.
Thank you,
Over
Professor.
to
Thank
you, Ani and Bobby. Yeah.
Thank you. Thank you, Janakiraman. So, hi everyone. Just 1 minute. I am going to share. Please let me know if you're able to see this.
Yes, sir.
Bobby, shall I start with these
Yes,
slides?
please.
Okay. Are you able to see the slides? What view? You're able to see just the slides, right? Okay, just 1 minute. Full screen. Are you able to see the slides full screen?
Yeah, it's
Yes.
correct.
Yes, sir.
Excellent.
Yes.
Excellent. So great. So I only have like 3 or 4 slides giving you a very high level overview of this course. So first of all, this course, of course, is titled, the course that Professor Bobby and I are teaching is called Electrical and Electronic Circuits. So from the name itself, you should understand there is a component where you have basic electrical circuits. There is a component where you also study electronic circuits. They are fundamentally different. Okay. And just 1 minute. So at a very high level, in 2 lines, if we were to tell you what the objectives are, what should you be able to do at the end of this course, right? You should be able to analyze linear circuits in the time and frequency domain. What does that mean? I think last term, you studied what linear circuits are. For any circuit for which superposition is valid is a linear circuit, right? And you learned how to analyze them in the time domain, which is basically we studied simple RC circuits, charging, discharging, things like that. And we also studied what happens if you apply AC, right, in the time domain and a little bit in the frequency domain. In this course, we will take that forward, especially in the frequency domain. You will understand systematic ways of analyzing these circuits, these linear circuits. Okay, so what are these linear circuits? Resistors, capacitors, inductors, transformers, right? These are the most common types of linear circuits. And in the second half of the course, so the first bullet point objective covers all it covers the electrical circuits. Okay, the second part covers electronic circuits. So electronic circuits normally use components that are not necessarily linear, right? They do not obey superposition. So we need to figure out how to understand these circuits, how to understand these components first, how to build circuits with them, how to understand these circuits. So we will cover some, to some level of electronics in the second half of the course. And we will learn several types of devices. We'll learn what the diode is. We will learn what a transistor is. A couple of types of transistors we will kind of introduce. Okay. And of course, this course directly takes off from the electronic systems thinking and circuits course, where we introduce you to, things like, KVL, KCL, superposition, power, DC sources, AC sources, things like that. This will directly start exactly from where we left off in that course, as far as circuit analysis goes. Now, a little bit more on the detailed content. So this is not necessarily in the same order or in the same way we will teach you, but broadly, okay, you'll be learning about, like I said, resistors, capacitors, inductors, transformers. We will be dealing with node mesh analysis review, but we will be using it. Basically, we are not going to reteach it. We are going to review it. We are going to use it in many of our analysis. Then we are going to teach you certain circuit theorems, right? There are something called Thevenin equivalent, Norton theorem, and so on. And we will introduce AC in a more systematic manner. Last time we just gave you a sinusoid. We did some certain frequency domain things, analysis with them. But, there are very systematic ways that happen to use complex numbers and vectors and so on. Simple vectors, simple complex numbers, right? Then there is a whole domain of electrical engineering that consistently uses frequency domain analysis, right? You will turn to time domain in certain situations, but a majority of your work may be done in the frequency domain in many areas of electrical engineering. So that is the Laplace domain or the frequency domain. There are various domains, but we are in this course, we will introduce what is useful for you for circuit analysis, which is the Laplace frequency domain. And associated with that, you can study frequency response, part of which you have studied for the filters, but again, more systematic ways of understanding complicated circuits. Then more complicated circuits such as, having, last semester we learned R and C only, right? This semester we will see what happens if you put R, L, and C, right? To figure out to make maybe filters, things like that. And finally, how to handle power. Voltage and current is okay, but you also need to handle power, okay? And so we will handle power, electrical power with AC systems. Then the next part of the course deals with techniques, analysis, understanding of electronic circuits. So that really starts with what are called dependent sources. So you need to understand how to handle, RLC, ideal voltage source, ideal current sources. There are what are called dependent sources. We will understand what that means. We will then talk about two-port networks. We will understand some network theorems associated with those two-port networks. And that will directly lead us to nonlinear circuits, right? Diodes and transistors, we'll understand their DC behavior, right? That is the level to which we can go. So what happens, if you, obviously they are nonlinear elements. If you apply one voltage, let's say V, to the input and we measure a current, if you double the voltage, you will not get double the current. You may get 4 times the current, you may get 3 times the current, you may get something else. So there is a certain behavior. We'll draw the current versus voltage or voltage versus current characteristics for these devices and get a good understanding of the circuit behavior of these elements. So this is kind of a more detailed syllabus of this course, you could say. And I will end with this. So there are primarily there is primarily one textbook for most of the electrical circuits part. That is the engineering circuit analysis by Haight, Kemerly, and Durbin, which is 8th edition was out in 2013. And the additional reference for the electronics portion is called Microelectronic Circuits, Theory and Applications by authors Sedra, Smith, and Chandorkar. 7th edition from 2017. Now, both of these have an Indian edition. And I would urge you to, gain access to these two textbooks. They will be very useful. Okay. And with that, I kind of have, given a very high level overview of the course. Bobby, I'll hand it over to you, request you to add if you have anything to add on the course structure, content itself.
Yeah, thank you, Aniruddhan. I have nothing more to add technically, but welcome to the course. And like the previous course that we taught, this time also this is going to be a discussion type of, recording with Aniruddhan and myself. That we will try to maintain, throughout the course. That's what we have planned. Then, as Aniruddhan mentioned, some ways of solving the circuits or to analyze the circuit. So while here you will see more maybe powerful methods that can be used to analyze even complex circuits and even to get more understanding of the circuit for the linear as well as non-linear circuits. So I'm sure you will enjoy this and you will also learn many new things from this. This is one of the fundamental courses of this whole program. There is no lab component for this. But there is another course where there is primarily there is a lab. So yeah. So if you have any questions, I think we are open.
We are open for questions. That's right. I'll stop sharing so that it will be easier for the students to. Yeah.
Yes.
Please go ahead, raise your hand, and we'll call you one by one. I think just 1 minute. I don't see. Somebody raised their hand and they were. Varun Raghav is who I see. Varun, please unmute yourself and ask.
Good evening, sir. Yes, sir. But sir, this is the course that came for the qualifier level, no, sir. Of that, this is the course which was part of the 4 subjects of the qualifier.
No, it is not. No, this is a second semester course.
Okay, sir, but this has lab, no, sir.
Sorry? No, this has no lab. I think Professor Bobby just mentioned that this has no lab component at all.
Okay, sir. So can you also say the procedure to buy the kit?
So maybe that we'll handle separately. So because this is for a second semester course, by now you should already have the kit if you are taking this course.
This session is mainly for the second term students. So I think so you are I think starting from the beginning. So this is not meant for the first term students. So this is only for those who have completed the EST course and come to the second term students. So you can hold off to your question. We can take it later, or you can write to us.
Correct. You can write to us. There will be a separate orientation, Varun, for you, for qualifier students.
Okay, sir. Thank you, sir.
Yeah. Prithvi?
Sir, yes, sir. I have a doubt, sir. Sir, similar to the ESTC course, at the time of we are nearing to the end of the course, we have learned about the communications and a glimpse of a communication, no, sir?
Correct.
So will there be any component or any subject of communication in this electrical and electronic circuits course?
No, it won't. Because EST, electronic systems thinking and circuits, put together a systems aspect and a circuits aspect, right? So the communications came under the systems aspect. This course is purely a circuits course. So it does not, you will not have aspects like communication systems. We will not be looking at more complicated systems, higher level systems, bigger systems.
Okay, sir.
Okay. Venkata Subhash.
Good evening, sir. I would like to ask one question. Is this course similar to ESTC, or is this a standard course? Will you be following any textbook?
Did you join late because I just finished showing the textbooks?
Yeah, sir. I'm sure you showed that, but even in ESTC, those textbooks are mentioned as useful links, but to be honest, like in ESTC, you haven't followed any textbook. I mean, at least for the curriculum.
No, it is not like that. When we prescribe a textbook, that means that whatever we teach will be covered in some chapters of that textbook.
Yeah.
Okay. So, for example, for ESTC, we had still prescribed Haidt and Kemerly. Whatever you learned, KVL, KCL, mesh analysis, loop analysis, they were all covered and in that textbook. It does not mean that we will cover the complete textbook in one course. That is very often not possible.
Yes, sir.
Okay. So, like I said, these two textbooks that we have mentioned here will act as good reference textbooks for you to refer to if you have doubts, want to learn more, want examples to work out, etc.
Yeah.
I hope that clarifies.
Yes, sir. To be straight, even this course is a kind of tailor-made.
Okay, so you're asking if this course is a tailor-made course or different. Well, no, it is not. This is actually it is tailor-made in the sense that there is a electronic circuits component. Okay, in that sense, it is putting together content that may be covered across 1 or 2 courses, 3 courses, and putting them together. Indeed, yes.
Okay, sir. And one more doubt was like, we are having a separate lab course along with this as co-requisite. Will that course be like doing at the end of the term, or like will it be will that also have some weekly work or something?
We will talk about the lab in as soon as we finish the Q&A for this course.
Okay, sir. Thank you.
Yeah. Anirban?
Yes, sir. Actually, my question was pretty similar to the question he asked. Actually, my question was that there are two separate subjects. One is this one, and the other one is the electronics lab. My question is that the electronics lab, will it be related to this subject? I mean,
we will talk about it. I understand your question.
Okay.
We will talk about it. Hopefully, once we tell you a little, I don't have slides for it, but we'll tell you orally. I hope that will answer all your questions. At that time, we can have a Q&A on that lab course as well.
Okay, so thank you.
Prabhanjan Kumar.
Yeah, hello, sir. So, sir, my query is that since this course may contain some sorts of simulation of the circuit also. So
No, I
do we
don't think
need?
so. As of now, we are not, I don't think we plan to add a simulation component. We have discussed it. If we ever decide to add it, we will let you know. Most likely it will happen towards the end of the course. Right?
Okay, yeah. So, sir, in this, you will have access to get MATLAB based on the student credential or some software?
That we will have to get back to you on that. I am not sure that, I'm not sure about that question. Okay. See, normally what we will do is we'll give you access to a software when you need it, when we reach that level in this curriculum. Before that, there is no need to. I think in a couple of semesters, when you do the DSP course, you might have projects, assignments which might require MATLAB. Most likely at that time only we can give you access to MATLAB.
Okay. Thank you, sir.
Yeah. Gaurav Verma. Okay. Saumendu Ray.
Sir, good evening.
Good evening.
So my question is, would there be any mathematical concepts required for this course which may not have been covered in Mathematics 1, like Laplace transforms or anything else?
So we will teach you Laplace transforms in this course. So that you don't have to worry about. You need to be comfortable with differentiation, integration, basic trigonometry, then complex numbers, basic complex numbers. This is what you need to know for this course.
Sure. Thank you.
Yeah. Okay.
So this is Gaurav. Yes, sir. Yeah. Thank you. Thank you for this opportunity. My question is one on the maths aspect. You just answered one question regarding maths concept requirement. But how about multivariable calculus? Will there be any
No,
part?
you will not need it. You will not need it for this course.
Okay. And then about the core electronics concept, you mentioned what all will be covered while explaining the curriculum for this course. How about the elements like op-amps? Will those be covered?
They will most likely not be covered. We might, if we have time in the course, we might tell you what an op-amp is. That is the level to which we might go, because I think by the end of this course, you will have enough background based on what you have learned in this course to understand what an ideal op-amp will look like. Okay, if we have time, we will do that. But primarily, op-amps are going to be covered in a separate course next term.
Next term. And
most likely either third or fourth term. One of these two terms, the op-amps course will appear.
Okay. Yeah, these are the two questions I had. Thank you.
Okay, thank you. Any other questions? Please raise your hand.
I think no more questions, Professor.
Okay, so maybe then Bobby will tell them a little bit about the electronics lab.
Yeah.
Do you want to get started or?
Yeah. So the electronics lab, it has two components, primarily some experiments that you will do regarding things basically that some of the things that you study in the digital and some of the things that you study in the this course, electrical and electronic circuits course. The experiments are based on that. So there will be about 8 experiments starting from, for example, in the circuit portion, you may even verify, some of the theorems that you study by making certain circuit, and then cross-checking the voltage and current using the kit that you have. So we will send you the material, in the sense there will be a recorded video, and then the procedure, in the sense aim of the experiment and what is expected and what you need to submit and so on. There may be some experiments where both components are involved, in the sense the circuit portion and the digital portion. So you have a small kit with you. The other than the analog kit, there are some components with you. So I think one of the op-amps, then a couple of diodes, resistors, capacitors, and you also have a light-dependent resistor. So the experiments are designed based on these components, and this is doable at home. But as a part of this program, you will also have a short visit to campus and demonstrate what you have done. When you do, if you face problems and if you need assistance, we will also have some arrangement to take care of that. So more details about that, we will come back to you, in the sense when you need to submit certain things and so on. You would like to add anything?
I think you have covered everything. I have nothing to add. I think Professor Bobby has given a high-level overview, half digital, half electrical and electronic circuits, and he has given you an idea of some of the components. On the digital side, you may have some ICs with logic gates, maybe some timer circuitry, because I think you saw that Professor Janakiraman talked about sequential circuits and combinational circuits. So you'll have some experiments which will combine both, most likely. And sequential circuits often require a clock, like a timing information. So it's quite possible that you might get a timer circuit, which you will have to build. It's not that the timer circuit will directly give you the clock directly. You might have to add some extra components to put the IC together with some extra components. But broadly, half digital, half analog. Not analog, half electrical circuits. Operation, there will be some submissions that you'll have to do during the semester, and there will be a portion that you will have to come and do and show in front of us, demonstrate in front of us. So it will have both components. That is what we expect. And the grade for the course will also include both. You will be evaluated on the sessional work as well as the final work.
And the duration of visit may be shorter. You may not need 4 days.
Correct. That also.
Days.
That's right.
So if possible, we'll try to manage it on a Saturday, Sunday, and so on. So that, because some of you are studying other programs, so we will try to accommodate in that way.
Okay, so let's see if there are questions. If you have questions, please raise your hand. And okay, Anirban has a question. Please go ahead, Anirban.
Sir, I have one question. Suppose I'm having for electronics lab, it is mentioned over there that the electrical and electronic circuit is a core requisite. So that does that mean that I'll have to complete it first, then I'll have to do the lab, or I can pursue both of them at the same time?
That is correct.
Yeah, you can do all that.
I can do both of them at the same time, right?
Yeah, in parallel.
Yes.
In parallel. Okay. Okay. Thank you, sir.
Yes, go ahead, Gaurav.
Sometime back, there was an email asking about when would we like to have this lab done. So is there still an option like we can have it in this term or after this term as proposed, like in May or June, or what would be the other option if that is still the case?
No, most likely, see, that depends on many other things, but I'll just tell you that we may not, in summer, for example, we may not be able to have 4 sessions. We may only be able to have 2, right? So you can pick from either one of them.
So 2 sessions of 2 days each.
Exactly. And you can pick one of them to come and showcase your lab, get it evaluated.
Okay.
Okay. But again, I mean, we are trying to squeeze it down to 2 days. Okay. That depends on a couple of factors. And only after that we can confirm. But we are giving you advance information that it's likely that it will get compressed down to 2 days.
My question was, is that still under consideration that this lab might happen in this May or June, or it can be clubbed with the later terms, like term 3?
Maybe
Or
I'm misunderstanding the question, maybe, but okay, I'll ask you in a different way. I'll tell you in a different way. If you are doing electronics lab in this term, you have to come here in May and June and get it evaluated.
Yeah, that's very clear, sir. So
Yeah,
if
that's
I
what I
have
was saying.
opted for if I have opted for the lab, then I'll have to do it in term 2. But
Correct.
the mail which we received was asking if we would like to have the lab sessions in this term or not.
Maybe if you want to do the course
Electronics lab.
later.
Sorry?
If you want to do this course later, that is of course possible.
No, that's not my intention.
the
So that
lab
mail
alone.
gave, the lab alone. Yeah. So when we were registering for our courses or choosing our 4 courses, at that moment we didn't have option to pay for this lab separately.
Prof, I
So
think
a separate.
this is more of a ops related question. So this is, I think you're talking about a G form that we shared. Is that what you're
Yes,
asking?
yes,
Yeah,
Girish, sir. Yes.
yeah. So see, it is because in the course registration it was not showing, so that's why we asked for that. So as professor said, if you're taking the lab here, so in this term, so you will have to come for the during in the month of May or June. So
Of course, sir, that's very clear. But that form gave an impression that we have an option either to do it in this term or club it with term 3 or later
no,
term.
no. That is not what we intended. It is just a form asking you to ask. The idea was of sending that form is whether you want to take up that course or that lab or not. That's all. It has
Not
nothing to
taking
do.
it.
Not taking means you're not registering for the course. That's all.
But we'll still have to apply or do that lab. If not now, but at some later point, right?
Yeah,
At
if you
least to
don't want to take
complete
up,
the foundation.
Yes. This is a compulsory course. If you don't
Lab.
want to take up the lab, then you can do it in next term if you want.
Okay, so
a
that
compulsory
way
course.
we can manage our travel. If someone is like, means I am from Delhi and I would like to club this lab sessions with the labs of term 3, will that be an option?
You mean to say that you don't want to come this time in the month of May and you don't want to register for the lab? That's what you're asking, is it?
I'm just looking at my options.
Gaurav,
I mean, for me,
Gaurav, maybe I'll clarify
traveling will
it.
be, yeah.
I'll
Yeah.
clarify it. See, the electronics lab course can be taken at the same time as digital systems and EEC course. Okay. It can be taken in a later semester as well. That is where the self-paced option comes. You cannot do the electronics lab before you do both of these courses. You can do it in the same term or later. Okay.
Later term. Okay.
You are perfectly welcome to do, for example, the theory courses now and do the lab course next term. There is no problem with that.
So that means I'll be covering 6 courses in the later term in term
No,
3.
that is also not
maybe.
possible. Again, the only reason you would, those constraints will still remain, right? You are not allowed to do 6 courses in one term. So those constraints, the whole idea of self-pacing is that within a maximum set of course credits and course CCC, you take a certain number of courses.
Okay.
Okay. You cannot violate the CCC just because you have decided to take a course later.
Okay. Okay. So I'll have to drop some other course if I'm taking lab in the later term.
You don't have to register. There's no dropping. No, you don't register for one of the courses so you'll complete your foundation level slightly later. Maybe.
Yeah. I got it. Got it. So, yeah. Thank you. Thanks for this clarification. Yeah.
Sure. Prabhanjan?
Yeah, it is more about the course registration in this term. So actually, as per the system.
That is, can you please take that question up separately with this thing, because this is primarily for these two courses.
Yeah, sir. Yeah.
Not
we will have
Yeah.
a separate doubt clearing session for that. So this is, if you have any questions related to the content of the course or anything, that you can ask here.
Okay. So one question only, this for electronics lab also we are going to have some separate dashboard kind of feature. There we can have a monitoring of the course progress, or it will be clubbed with the both the courses, like a digital system and electrical.
I didn't, Bobby, did you understand? I didn't understand the question.
I don't know. Maybe
No, he's. I think what Prabhanjan means is, will there be a separate course, the course portal, like how we have for for the all other theory courses?
Yeah. Yes.
I don't understand. I thought every course has a portal. No.
Yeah, this also will have. This also will
I
have.
thought every theory course has a separate portal. No.
Yes, we do have.
Yeah.
Yes.
Okay.
Pratham?
Yes, good evening, sir. Sir, basically, my question is also related to electronics lab. Two questions primarily. First question related to this two courses we have in this second term, that is basic digital systems and EEC. So by combining that, we have the lab, means we are using the knowledge of both the courses, or it is affiliated to EEC only.
Both.
Okay, means for doing the electronics lab course, we have the knowledge of both. Means we have to do parallelly this basic digital systems and this electronic circuits.
Yes.
Okay. So therefore, we are considering this electronics lab as a different course. Means like in ESTC, we have lab. We have lab together. Means with the theory part, we have lab. Means not doing lab means not completing the course. Here, electronics lab is a separate.
It's a
separate course.
It's a separate course, but it needs to be run in parallel with other two courses, or you can do it later.
Or yes, or the option is like on completing BDS and EEC, afterwards we can complete this electronics lab. So as a safety means I have fill up that Google form, I want to take this, or if I change my schedule, or I not, maybe not now, so I can also take it later in later terms.
Yes.
Okay, sir.
Subhashish?
Good evening, sir. Am I audible?
Yes, you are.
Yes, sir. My question was that the lab course, it is considered as a, like, I contacted the support team regarding this, since we will be taking 5 courses essentially if we are taking lab course as its own separate course. So is it like some project or something, because that is what support team had said?
No, it is like a lab course, any other laboratory course.
So how would that?
I don't understand what a project course means, because so far
See,
we have not had a project course in this BS in electronic systems.
So, see, one thing you should understand, Subhashish, is that so this course will not have the end term like how we have for theory exams. So it's for the theory courses. See, theory courses you have this quiz 1, quiz 2, and end term exam, which where you have to go to a particular exam center and take, right? So that will not be there for the electronics lab. So that's why you can take up this particular course as an additional thing.
Okay, so depending on whether we are giving exam or not, we can take multiple, like more than 4 courses in a term.
The
No,
maximum, the maximum theory courses that you can take in a term is only 4.
Exactly. So, Girish, I think there is a question of whether, because what the limit is and how it applies. So the limit is a credit limit, first of all, number of credits and number of theory courses. And a combination of theory courses and lab courses. That is the way it is normally done, right? We cannot give you, 1 theory and 10 labs. You will not be able to handle it. We cannot give you 10 theory courses also. You will not be able to handle it. There is a certain balance of number of theory courses and lab courses that works well for a curriculum. Okay. So 4 theory plus 1 lab is probably the most you will see in this curriculum, I think.
Okay, sir. And one last question regarding the prerequisites. Like in the website, it is mentioned as Maths 1 and ESTC as the prerequisite, but is the basic digital systems also necessary for understanding this electronics lab?
Yes.
So can we consider BDS as also as another core requisite for electronics lab?
I think it is already listed as a core requisite. Both BDS and EEC have been listed as core requisites for this lab.
Professor, in the website, it's not like that.
Okay, we need to correct it then.
Oh, okay, sir.
Okay. BDS is a prerequisite, is a core requisite for this course.
Okay,
we will
sir, thanks, sir.
Thanks for bringing this to our attention. We will correct it.
Thank you, sir.
Sam?
Hello, good evening. So this is as per the discussion. I thinking that this is some theory. This course includes some theory parts, and this some kind of experiments there. Okay, like every week we are releasing some kind of theory part and some kind of experiments we have to perform at home there. Okay, I think.
There will not be a lot of theory. So you are expected to use the theory that you learnt in the previous course and the ongoing courses to work on the lab experiment.
Okay,
think of
like
it
we
that
had
way.
done in the
video that is
yeah,
released, the video that is released will explain what you are trying to do and how to do it.
Okay, like that we have done in the lab course at the campus there. Okay,
that is correct.
Same thing there. Okay, we need to perform the experiments, note the readings and all that, and submit in the some particular format. If you are going to provide that, that will be there, and it will be a weekly basis, like the other courses that.
So a couple of things. That is not the only way in which you will be asked to submit your experiment results. There are various ways, because we may even ask you to demonstrate it live to an TA. We may ask you to take a video
like
and submit it, but we will get you to submit it in some form to be evaluated. Because different experiments need to be evaluated in different ways.
Right. So yeah, there are either ways are there for the to demonstrate the output of that particular experiment and all that there. Okay. Got it.
Okay. Yeah, thanks. Anybody else? I think Aditya Prakash Gupta.
Yes, sir. Good evening, sir. Am I audible? Sir, my question is related to lab only. Sir, as we have previous lab 4D lab component of ESCC and C programming, will this lab component also a 4D lab component similar to our previous?
I didn't understand that last question. Could you please repeat that?
No,
Sir,
what is the... Yeah. So this lab, as I mentioned, we will try to manage it in 2 days, if that's the question.
okay, sir.
Yeah.
Both, sir, basic digital systems and this lab.
Yeah, it's one lab. See,
Okay,
you
okay.
will come and demonstrate one lab experiment that has both components. That we will explain to you when
Okay,
that
sir.
comes.
Okay. Thank you, sir.
Thank you.
Tejas?
Yes, sir. My question is that during choosing of the subjects for this course, actually I was told that we have to select the lab component also. So is that correct, sir? Because and we are told that you have to fill a Google form, which was provided through email. So we filled that, and I have chosen the lab component also for this term. So is it possible I can revert that process? Means can I take this lab in next term in December?
Yes, you can.
So filling of form will not be the means final conclusion that
It is not.
I have selected. Okay,
It is
fine.
not. The final conclusion is what you have registered on your this thing in your registration.
Yeah, dashboard. Okay, fine, sir. Thank you.
Girish, that is correct, no?
So Professor, what has happened is the electronics lab. So like other courses, so it was not appearing in the dashboard for them to register. So that is why we sent a form asking them, if you want to register for the lab, then you have to fill the form. So that is what it is. Yeah, but it is
How do they drop it
student's
then?
choice.
Yeah, okay, good.
Yeah.
If they want to drop it, should we ask them to send you an email? Send an email to support.
No,
or
they
how
still have not made the payment. So am I correct, Tejas?
Yes,
I think
yes,
you
right,
still
right,
have, we have not sent the payment link yet.
Okay.
So if you do not want, you send us an email telling that I have filled the Google form, but I don't want to attend the lab this time.
Yeah.
Okay, fine, sir. I will do the same. Okay.
So if you are doing the lab later, it will be a good opportunity to revise the topics.
Yes. Yes, sir. Yes. Thank you.
Thank you.
Dhruv?
Good evening, sir. Sir, you just said that digital system is a core requisite for electronics lab. Sir, like I have taken electrical and electronic circuits and I have not taken digital systems. So I can't attend electronics lab.
That is correct. You will not be able to do the electronics lab.
But sir, on website, it was mentioned earlier that core requisite is only electrical and electronic circuit.
We will correct it. That's clearly, an oversight. We will correct it.
Sir, but I chose the subjects accordingly.
I understand. So what we can do is we can, in such a case, we will go back and if you want to re-register for something else, we will talk and see if we can do it. Girish, let us figure out what we can do in this case.
Yes, Professor. I think what happens is if we are adding the as a digital systems as the core requisite in the workflow, also we have to make that change.
Yes.
So let's discuss that, Prof. I think that's possible. Okay.
Yeah.
Sir, maybe the course registration window can open once again so that I can select that, and because I wanted to do lab in this term only.
Yeah, Dhruv, just give us some time. So we'll have to discuss this and then we'll let you know.
Yeah. But anyway, Dhruv, you will not be punished for our mistake.
No, sir, I just wanted to complete
That's
that.
what. So if we are, this is something which we have not marked in the website. So you will not be punished for that. In the sense, you will be enabled to do the other course and then do the lab.
Okay. Thank you, sir.
We will come back to you, and others how to do this. We will come back to you.
Okay, there are some students who already asked a question. I'm not sure if Subhashish, do you have one more question?
Yes, sir. This is regarding the components that we will require for the lab. So.
Okay,
So-
we will share those details with you. Okay, in a few days, fairly soon.
So we'll have to purchase them on our own, or can we purchase directly from IIT Madras?
You can't purchase it from IIT Madras. Okay. Well, so what we can do is you can't purchase them from IIT Madras, but we do have, just like we bought the kits, there was a supplier for the kits, right? Similarly, we have identified a supplier for these components who will be able to, whom you can purchase from. I'll put it that way.
Okay, sir. And this time there won't be any shortage or anything like that, no, sir?
Shortage of what?
Yeah, these are components which are easily available.
That's it. These are components which are easily available. That
Yes,
will
sir,
not
because last time the ADLM kit acquiring that was a very big pain, sir.
Yeah. That kind of pain will not be there this time.
Yes.
This
These
is
are all routinely available.
Yeah. This is some diodes, LEDs, transistors, all that is easily available here.
And 555 timer maybe and so on. They are all very standard resistors, capacitors. They are all very standard components.
Okay, thank you, sir.
Yeah. Pratham, did you have another question?
Sir, one last thing I want to ask. Today only I asked to Janki sir that what would be doing in BDS and how it is related to ESTC. The same how question for EEC, like he told me, like storage systems and the binary systems, we will pick up the BDS system from there. So how the EEC would be pick up from the ESTC course? Means from which part?
Yeah.
Means
So
like LC circuit and
that was there in my slides. So the first thing I said was review of, basic circuit. So anything we start, we will typically start with your basic circuit analysis, simple circuits, RC, something like that, DC sources, AC sources, and so on. We'll start from there.
And here I can see that maths is important. So the equations like differential, double differential also will come, or how it might be, means how maths would be, how we will competing with maths here.
I think it cannot be detailed in every little way, but I'll tell you two cases. You will need differentiation integration, okay, for sure. And you will need complex analysis, complex numbers, simple complex algebra. You will need these two aspects from maths 1. You will definitely need.
Okay, means and what about differential equations that we use in the circuit laws and all?
Yes, you will need them. You will indeed need them.
Okay.
Yeah, I mean, it's not full about differential equation. I mean, those are used to solve circuits, so you will enjoy more.
That only I was waiting.
Yeah.
Okay, sir. Thank you.
Tejas, do you have a question?
No, sir. No.
Okay, I'll lower your hand then. Are there any other questions about electrical and electronic circuits or the electronics lab? Or if you still have residual questions about basic digital systems, we can try to clarify with our limited knowledge.
Hello, sir.
Yes, Ayush.
Sir, I have a general doubt that this time in ESTC, I got very average score like 54. Sir, what is the key to make this score, sir, improve this score towards 90 or something higher score, sir? So your guidance is further important, sir.
Bobby?
Yeah. Solve more problems. So we will, in the program, in the course itself, while we are discussing itself, we are taking some problems and solving it, but that's not sufficient. Unless otherwise you do it by yourself. It's like, we seeing somebody driving or you driving it. So you need to have sufficient driving experience to drive well. So basically you have to solve more problems. That way, more confidence and more clarity will come when using the theorems and so on. It's not a difficult course, but some effort is required, to learn new things and then practice it. And what you study in this course, will be useful throughout your career.
Thank you, sir.
Thank you.
Any other questions?
Yeah, there is one question for Girish, I think. When the grading document will be shared?
Yeah.
Okay, he says from tomorrow.
Excellent. Okay. So thanks a lot to all of you for attending this orientation session for all 3 courses. From our side, we wish you all the best for the upcoming term.
Yes.
Thank you, sir.
Thank you. Thank you, professors. Thank you.
All the best.
Thank
you.
Thank you.
Thank you.
Thank you, sir.
Yeah, I think the live streaming is still on.
Yes.
I'll inform Mahesh.
Yeah.
One second.
Is Rohit part of our team?
No, I think he's a student.
Oh, he stopped. He dropped off.
Either live stream, can you just switch off, Mahesh? Yeah. Just update me once you stop the live stream.